All right, we have been talking about arithmetic and geometric sequences. Today we're going to talk about series. So this first page is just kind of series in general, because not all series are arithmetic or geometric. We're going to talk about series in general, just a little bit, kind of skip around on this to get some vocabulary, and then we'll move on to actually the arithmetic stuff. So your definition of a series, all a series is the sum of the terms in a sequence. So the sequence would be the numbers listed out. The series is the sum of those terms, or the sum of those terms, sum of part of those terms. I know the sum of some, different sums. Anyway, I'll explain it better in a minute. I'm going to give you a couple of little examples. So if I give you a sequence that's like 2, 4, 6, 8, that's the series for that sequence is going to be 20, because it's literally just adding up those numbers. Okay. The sequence, if I give you a 4, 8, 12, 16, then it goes on forever like that. Then the series here is going to be infinite. If I give you 1/3, 1/6, 1/12, 1/24, and so on, that series is actually 1. We'll see why that happens a little later. Just take my word for it right now. But yeah, just trust me, even though it goes on to infinity. All right, so sequence, the terms listed out. Series is a sum. That's the main difference between the two. All right, so then we have also partial sums. So partial sums, that definition is just the sum of a specified number of terms in a sequence. And it would be a capital S with a lowercase n to represent that. So let's look at number 1. It says find the partial sum, because I don't want it's going to go on to infinity. Partial sum for each given sequence. So this S7, when you have a sequence like this, it implies that you want the first 7. Well, I only have 1, 2, 3, 4, 5 of those, so I need 6 and 7. What are the next two going to be? 22 and 26, right? So then when I want the sum of the first 7 terms, I literally just add those up. So add those up. Okay, it's just 98. Easy enough? All right, so 2, 3, and 4 are pretty much just like that, but with different numbers. I think we don't need to do those for sure. But I want to jump down to number 5. Not that it's any more difficult, it's just different. So I want the sum of the first 5 terms, and they give me a rule this time instead. So I have to figure out what those are. Remember, n is literally the term number. So I have to start with the first term number. So that's going to be 1 cubed plus then 2 cubed plus 3 cubed plus 4 cubed plus 5 cubed. And then you can just put them in your calculator exactly like that, or you can figure them out. That's going to be 1 plus 8 plus 27 plus what? What's 4 cubed? 64. And then 5 cubed is 125. Okay. So S5 then is going to give me 225. Any questions about any of that right now? All right. Very basic. So let's talk some notation. We've got summation notation. All right. It says a way to represent a series using the Greek letter. What's this Greek letter? Anybody know? It is not E. It is sigma. You are not ready for college if you don't know your Greek letters. Okay. So Greek letter sigma to denote the sum. So summation notation can also be called sigma notation. It represents a sum. So you've got this sigma here. You're going to have a number above it, and then, or it could be infinity. And then n equals, and this letter can change also. I mean, they all mean n, but it can be whatever. This is where you start. This is where you end. So we're not always doing the first however many. In this case, I am. It would be the first 5 because I'm going from term 1 to term 5. All right, so this top letter is the last term number. And the bottom number is the first term number. Then, so we want the sum of terms 1 through 5 of this rule right here. So this is just your formula for the sequence, whatever it may be. So when I want to find the sum of the series above, this would be 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4 plus 2 times 5. And again, I mean, these are pretty easy to figure out here, but you can type it in the calculator like that, or you can figure them out, whatever. You get 30. I know you can do that in the calculator. You don't have to worry about that. Any questions? Oh, you should be able to do it without a calculator, too. Let me just throw that out there. All right, on the back. So I want to look at number 11, because number 11, we do not start with 1. We start with 2. Which is fine, and it's a K and not an N, totally fine. So we start with whatever the first one is. So it's 2. I substitute in the 2, I'm going to get 2 squared minus 2. Then I keep going until I get to 8, plus 3 squared minus 3, plus 4 squared minus 4, plus 5 squared minus 5, plus 6 squared minus 6, plus 7 squared minus 7, plus 8 squared minus 8. And again, should be capable of figuring that out without a calculator, but you can also just type that in exactly like it looks, and it will do all that for you, so you're not trying to do weird things. And find that sum. We're good? So most of the rest of these on the page are pretty much the same thing. You just start with 1, substitute it in, you can figure that stuff out. I do want to look at 15 though. Because what the difference is on 15 and the rest is that we have this negative 9/4 out in front. So just like anything else you do, you have to do negative 9/4 after you actually find the sum. And we're going from 1 to 6. So when I substitute in 1, 1 squared is 1 times 2 plus 7 is 9. Plus, when I substitute in 2, 2 squared is 4 times 2 is 8 plus 7 is 15. Substitute in 3. 3 squared is 9 times 2 is 18 plus 7 is 25. All right, so you find the rest of those. What's the next number? 39. Then what? 57. Good. Then what? 79. Good. All right, so then we'd add up what's in there, or again, you can kind of put it all in the calculator at the same time, but that's going to equal negative 9/4 times 224. Then when you multiply those, your final answer is negative 504. All right, what questions do you have? All right, so that's the basics about series in general. We're really going to look at them more from an arithmetic and geometric standpoint, but we still had to know the basics of how they work. So grab your next sheet of paper. It is going on 153. So we've talked about arithmetic sequences. We are going to look at what an arithmetic series is. It is just the sum of an arithmetic sequence. It's that easy. So when I want to find the sum of that, here's the formula that I use. S sub n is equal to n times a1 plus an over 2. Looks just like that. Okay, so where n is the number of terms, a1 is the first term, and an is the last term. And that means the first term in the series. It doesn't necessarily always mean that it's going to be the first term of the sequence itself. So when we look at number 1 here, it says find the indicated sum for each arithmetic series. So notice we have addition signs in here and not commas. And we want S18. So if you actually have it listed out like this, this does mean just the sum of the first 18 terms. And we don't need to go figure them out. What I do need, though, is in order to do that, I need n. What is n? 18. I need a1, that's 7. And then I'm going to need a18 in order to figure that out. I mean, I could keep finding them, but instead I'd rather use the little rule we know how to do. In order to do that and use this, I have to know d. What's d? 3. Okay, it's positive 3. So in this case here, for me to figure out what a18 is equal to d, which is 3, times 18 minus 1 plus 7. So when you do that, what do we get? 58. Good. So now to actually find the sum that I want, I need a1, I need n, and I need a18. I've got everything I need. So the sum of the first 18 terms is n, which is 18, times a1, which is 7, plus a18, which is 58, over 2. And then I wouldn't simplify. Like, I would put it in the calculator just like that, so you don't accidentally add wrong or divide, something ridiculous, which we're all capable of. All right. What do we get? 585? All right. Are there any questions at this point? Good. Then you do number 2. So I got negative 3010. You agree with that? And somebody asked me last period if they could have put 50 minus 222 instead of plus a negative. Absolutely. I did it that way, though, because I had some people thinking we subtract. But also, sometimes I've already written my addition sign, so instead of fixing it, I'll just make it a negative 222 like it is. But if you did 50 minus 222, it's the same thing. It's fine. All right, any questions? All right, let's jump down to number 5. All right, so the difference here with number 5 is that they don't have it listed out. Okay, we have this summation notation. They're using k instead of n. That's fine. We're going from 1 to 10. So I still have to have the same types of information here. I still have to know what n is. What is n? 10. right? Then I need A1, which I don't have, and I need A10, which I don't have. But I don't need D in this case because I don't have to come up with the rule. There's one already there. So to find A1, I substitute 1 in. 6 times 1 is 6, plus 1 is 7. I substitute 10 in. That's 60 plus 1 is 61. So I've got everything I need. So the sum of the first 10 terms is 10 times 7 plus 61 over 2. Okay, should get 340. Yes? Okay. We all good? Awesome. All right. Flip it over on the back. Let's look at number 9. So number 9, we're going from 4 to 17, right? So the first term is really A4. It's not A1. And I need N. What is N here? It's not 17. I don't have 17 terms. If I'm going from 4 to 17, I don't have 17 terms. It is. Because you subtracted and add 1, right? It's not 13. Because if this is 13, 17 minus 4 is 13, then the one we just did that went from 1 to 10, N should have been 9, right? Because 10 minus 1 is 9. Remember, your birthday, you're not 1 until your first birthday. So that whole first year of life, you were 0. That's why you don't have to do that for your birthday. But for N here, N is equal to the last term minus the first term number plus 1. You got to add that 1. So N is 14 here. Then I need A4 and I need A17. So 5 times 4 is 20 minus 27 is negative 7. 17 times 5 is, let's see, that's 85 minus 27. Give me, what's 58? Yeah. 58. Okay. So now we have all the pieces. The sum of the first n terms. Oh, but I know what n is, dang it. It's not the sum of the first 14 terms. It's just the sum of 14 of the terms, which is fine because it's all identified up there. That's equal to 14 times negative 7 plus 58 over 2. $357. All right, so number 10, we're not going to do number 10. All I want to know in number 10 is what does n equal? So it's going to be 38 minus 3 plus 1, right? So n is 36. Make sure you can find n in the correct way so that you are good. Okay, questions on that? All right, I don't think we need to actually do the problem. I think you get the hang of that. So let's look at these application problems. So Michaela is training for a marathon. She ran 2.4 miles the first day, 2.55 miles the second day, 2.7 miles the third day. If this pattern continues, find the total distance she ran after 60 days. All right, so what is n? $60, right? Because I went the 60 days. 60. A1 would be what she ran the first day, which is 2.4. I'm going to need A60, but in order to find that, I'm going to need D. What is D? 0.15. Okay, good. So then I have to find that. That means that A60 is going to be equal to 0.15 times 60 minus 1 plus 2.4. You should get 11.25. Okay. So in order to actually find the sum, I need the n, I need a1, and I need a60. I've got all that stuff. So the sum of the first 60 days is equal to 60 times 2.4 plus 11.25 over 2. Make sure you are actually finding these numbers as well, because there's still some people that are having some typing in the calculator issues, and I want to make sure that we get all that cleared up. We all good? All right, let's look at number 12. Tickets for a concert opened up for sale online. The number of people that purchased tickets in each of the first 4 minutes is shown in the table to the left. If this pattern continues and the concert venue can hold a maximum of 75,000 people, find the number of tickets left after the first 2 hours. All right, so what do you think n is? 120, good. Because it says 2 hours, but this is in minutes, so I need that in minutes, so my n is 120. A1 is going to be 35. I'm going to need A120. In order to find that, I need D. What is that going to be? 8. So now I can find A120. That's equal to 8 times 120 minus 1 plus 35. Get 987. So then I need the sum of the first 120 minutes. That's going to be 120 times 35 plus 987 over 2. So that gives me 61,320. Is that my final answer? No, because I have to make sure that I read the question. What does that number represent? How many tickets have sold in 2 hours? This says find the number of tickets left after the first 2 hours. So I have to take that 75,000 and subtract 61,320. I don't have that number written down. 13680. Thank you. That's how many tickets are left. Tickets. That says tickets. All right. Any questions at all? All right. Number 13 is a little bit different. It says a brick retention wall was built such that the bottom row has 200 bricks and each row thereafter has 4 bricks fewer than the row beneath it. If 3,000 bricks were used, how many rows tall is the wall? All right, so what is, let's see, what does this 200 represent? The bottom row, which we, even though it's the bottom row, we can use it as the first row, right? Because we can go from the bottom up. So we'll say that A1 is 200. And 4 bricks fewer, what does that represent? D, the constant difference. So D is equal to what? -4, good. What does that 3,000 represent? The total. That's the sum, right? The sum of the n rows, but we don't even know what that is. That's 3,000. And n, we don't know. That's what we're looking for. Okay? So what I have then is, I have this S of n, I'm going to write this down over here, equals n times A1 plus AN over 2. That's our rule, right? So I'm going to substitute in what I know. I know the sum, it's 3,000. That's equal to n, which I don't know, times A1, which is 200, plus AN. I don't want to write AN here though, because then I'd have two variables and I don't want that, but it's all going to be over 2. So I need to go figure out what I can put in for AN. I can come up with a rule that looks like this, right? I know that AN has to equal D, which is that -4, times N minus 1 plus A1, which is 200, right? It's just your sequence rule. So that means that this is going to equal -4N plus 4 plus 200. So AN is equal to -4N plus 204. So now if I put that part in here, then I won't have two variables, right? So it'll be plus -4N plus 204. So then I got to clean that up a little bit. I'm going to get 3,000 equals N times -4N plus 404 over 2. So I can reduce that fraction. Mathematically, what's really happening is you got to factor something out of the numerator and reduce. But we can skip those steps. But you cannot just take 404 and divide it by 2, right? If there's addition there, you got to be able to divide everything by 2. So we get 3,000 is equal to N times -2N plus 202. Now I'm trying to solve for N, right? Figure out what N is. And so when I do this and I'm here, sometimes I want to distribute, sometimes I don't. I think here I'm going to need to because I'm going to end up with a quadratic. So I'm going to have to set it equal to 0 eventually. So this is going to give me 3,000 equals -2N squared plus 202N. So when I set it equal to 0, I would really like my squared term to stay positive. So I'm going to move everything over to the left. So I'm going to get 2N squared minus 202N plus 3,000 equals 0. What would be negative? No, because I'm moving everything to the left, and it's right there, and it's positive. Can I factor out a GCF? 2. So I can factor out the 2, and that's going to leave me with N squared minus 101N plus 1,500 equals 0. Now, what's in those parentheses there, maybe it factors, maybe it doesn't. If there's big, obscure numbers, maybe you don't even want to mess with that. And what would another option be besides factoring? Quadratic formula. And I'm going to tell you right now it doesn't factor, so you don't even want to waste your time with that. But you need to put this into the quadratic formula and find your n's. Go for it. Sing the song if you need to. That tune goes through my head every time I write it down too. You're going to get 2 answers, and you need to find them both. Find them both as a decimal. If the calculator gives you like an exact something, that give the decimal. Okay, so you should have gotten 18.092, and I didn't make my come on. And 82.908. Okay, So those are the two things that I got. When you get two answers, sometimes both of them work. Now, if one of them was negative, it clearly would not be, it would be the one that we don't use. But maybe we use both of them. We'll have to figure that out in a second. But what does n even represent? The number of rows, right? So I got to see if, what kind of answers these actually give me. I mean, they're going to give me something because it works as long as I did it correctly. So I'm going to take these and I'm going to substitute it in here and see what this gives me, right? So if I want to find, let's use 18 first, and we'll just use 18 because it's the number of rows. You're not going to have a partial row anyway, right? So we'll use 18. So A18 is going to equal negative 4 times 18 minus 1 plus 200. So what does A18 end up giving me? You get 132, right? And what does that number represent? How many bricks are in that row? So there's 132 bricks in the 18th row, okay, counting from the bottom. That seems legit. I don't really see a problem with that one. So then let's try the other one. We'll do 83, okay? Or you can't have partial row, we can do 82. That's fine. We'll do 82. So A82 is going to equal negative 4 times 82 minus 1 plus 200. What does that give you? Negative what? 124. All right, so does that number make sense? No, because you can't have a negative number of bricks, right? But if you don't even know what these numbers represent, it's hard to figure out whether or not it makes sense. So the 82, even though it gives me an answer mathematically, that doesn't make any sense. My answer is 18. So there are 18 rows. And there you go. Okay. What questions do you have? You got to be able to apply your algebra and know what to do when, no matter what situation you're in. Okay? Go ahead and glue or tape that in.